Morning, afternoon, night, whatever it is for you when you watch the video. We're going to go ahead and finally extend what we were talking about, well, 2 weeks ago now. Before spring break, we were talking about how to solve angles using trigonometry. Solve sides using trigonometry. Now, we're going to learn how to solve missing angles using trigonometry. So, let's hop right into it, shall we? Very big picture. And I'll extend this, give me some room to, of course it's black. That'd be good enough. Make this. There we go. Place to work. All right. So, very first thing, as always, anytime we're doing anything related to trigonometry, you need to remember so, and toa. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent, right? If this is confusing, you should rewatch the video from, the last trigonometry video, because you need to know this. But we're going to jump right into it, because not much has changed. This is all almost exactly the same thing that we were doing a little while ago, with very little differences. So now our x is right here where the angle would be. Now, that's mildly uncomfortable, but I'm going to show you that it's actually kind of easier. So our x is here, and we've got this side and this side. Well, let's just figure out what the sides are. Make it easy. Let's just do SOHCAHTOA. Let's figure out if we have an OH, AH, or OA, right? So if I go across from this angle, across the triangle from this angle, that is the opposite side. It's always opposite because it's the side that doesn't touch the angle. So we have an opposite, don't we? We have opposite, opposite. Opposite, I hope that's right. I just started this video right now, like in the morning, so, forgive me if I mess up some stuff. All right, so opposite side is 24, right? Cool. And now let's figure out what this other guy is. Select. Right. Well, I would always do I would go for the opposite side first, right? And then I go to the right angle. It's an arrow that points, right, to the hypotenuse. And would you look at that, there's a number there. So we also have a hypotenuse. And it's 60. Hypotenuse. Hypotenuse. Yeah, good enough. All right. Well, and we don't have an adjacent side. And you can see that because the side that's next to the angle that isn't the hypotenuse has no number. So we have no A. So come over here, we've got OH. And OH is the very first one. No A, no A. Those two are out. We're doing sine. So we're going to set it up just like we normally would. Sine, sorry, I hit my mic. Sine of the angle, which just happens to be x, right? Sine of the angle equals... Well, using SOHCAHTOA, S-O-H, sine equals opposite over hypotenuse. Opposite, which is 24, over hypotenuse, which is 60. Cool. We're almost done. We almost solved it. So we've got sine of the angle equals 24 over 60. X is our angle, and normally we want to get things away from x, right? The problem is how do we do that with sine? I mean, if this was multiplication, we would divide. If it was, addition, we would subtract. You do the opposite, right? If it was squared, you would square root. It's none of that. This is sine. So what in the world is opposite of sine? And I know that some of you said cosine. I don't know why students always say that, but I know you just said that or thought it. And you're wrong. It's not that. If you look at your calculator, I'll pull it up real quick. Where's my mouse? There we go. The computer calculator is a little weird. In other calculators, you'll see it, but this one has a little trigonometry thing. So you've got sine, cosine, and tangent, right? But if you hit second, you get this. Sine to the -1, cosine to the -1 power, tangent to the -1 power. These are called inverse sine, cosine, and tangent. Inverse sine, inverse cosine, inverse tangent. These are what you use to solve for angles that are missing. So we're going to do that to both sides. Now what that looks like is really, really, really easy. It's sine to the -1 power. Oh, it's going to be a pain in the butt to do here. I guess not. That wasn't that hard, actually. Okay. So it's going to be sine to the net. I'm trying to make it look pretty, which is hard to do. All right. Sine to the -1 power to everything. Right? Just like when you square root, you just square root the whole equation, and then it cancels out on one side. Here, the sine to the -1, the inverse sine and the sine cancel. But just like distribution, you have to transfer it. So you've got x degrees equals sine to the -1 power. I don't want to do this. I guess I'll just draw it. It'll look ugly. It's fine. Oh, that line was almost good. Sine to the -1 power of 24 over 60. All right, that's what we put in the calculator. So how in the world do we put that in the calculator? Well, you're going to hit 24, and then, what's the alt code for divide? Oh, I got it. All right. 24 divided by 60. Oh, let me do this the way we did it before. 24, then the division sign, then 60, then equals second and trig function. Well, I'll put sine, but it'll be the exact same every single time you solve for an angle. And now, lastly, how do we actually put that in the calculator? Most calculators, excuse me, most calculators, when you hit second, sine, cosine, and tangent are already here, like where you're working. For the Windows 10 calculator, you have to specifically go to trigonometry, and then it has its own second button here, which, mind you, threw me off when I was trying to figure out what was going on. So, yes, you need to go. And this is the only time I've ever seen it done this. On your iPhone, if you turn your iPhone sideways, it'll turn into a scientific calculator. You can hit second, and it'll bring up the inverse, sine, cosine, and tangents. Most calculators, normal, like handheld calculators, are going to have the second function. But regardless, find sine, cosine, and tangent. You're going to hit second to turn them into inverse. So let's do exactly what I said we're going to do. 24 divided by 60 equals. Now we go to trig, second, right? And then our trig function, which is sine. Boom. That angle is 23.58, because this would round up because of the 8, 23.58 degrees. Where is it? Equals, what is it? 23.58. There you go. That's it. You're rare. I mean, very much like the sides, you're very, very rarely going to get a solid number. There's not a single solid number answer on the quiz. They're all decimals because trig is really hard to make whole numbers out of. Really, really hard. So, but yeah, there you go. So I'm going to do 2 more examples. We're going to go significantly faster, but we're going to do 2 more examples, and then we should be good to go. All right, so let me Oh, can I go back actually? Can I undo? Hey, I can. All right, I'm going to keep that calculator thing there, mostly because it's important. It's important, it's useful, and we can use it twice, and I don't want to have to keep working. And if we switch this to trig, we switch this to side, it'll apply to everything. All right, so next practice problem. Let's do this situation. There we go. All right, so I'm gonna go through the exact same process because I am a creature of habit. I'm gonna go to my angle and I'm gonna go straight across from it to the opposite side, which I do not have. No O, which, well, frankly, already narrows it down as to which one you're going to use. This one has an O, so that's out. This one has an O, so that's out. So it would have to be cosine. It has to be this one. So let's figure out our adjacent and our hypotenuse. Well, you know our hypotenuse because you can go from the right angle straight towards the hypotenuse. So you know our hypotenuse is 642 miles. This is a very, very big triangle. And now, if there's no opposite side, and you have the hypotenuse, that leaves this side right here, which is named the adjacent. And by process of elimination, we have figured out that the adjacent side is 568. Put it over here. All right. So we figured those two out, which means we can already set up our equation pretty easily. We know cosine of the angle, so cosine of x equals, there we go, equals AH. All right, A is adjacent, H is hypotenuse. A is on top. Adjacent over hypotenuse. So 568 over 642. And now we need to do the opposite. We need to get x by itself. We need to do the opposite of cosine, which you now know is the inverse, right? So we're going to do, oh, this is going to be terrible. Oh, I am never doing that again. Oh, man. By the way, my handwriting on the whiteboard is just as bad. My handwriting is terrible, so you guys have actually gotten a much better situation here on e-learning, at least with me. So, yeah, cosine to the negative one, inverse cosine to both sides. This cosine cancels out. And then you're left with x degrees equals cosine to the negative 1 of oh, that was a good line. Oh, I'm proud of that one. 568 over 642. All right, so in our calculators, on our calculadores, we're just going to punch this in right here. Side divided by side equals second trig function. So come up here, you've got your side divided by your side, and then you hit second and the trig function. So our first side is 568 divided by our second side, 642. We hit equals, go to trig, hit second, and then our trig function, which is cosine. That seems very close to the first one, but well, whatever. So for this one, x equals 27.78 degrees. There we go. So we got one more practice problem. And then while I set that up, I will tell you real quick why trig even exists, or at least why this is important or was important. It still is important, actually. More people use trig in real life than you ever realize, because it's the only way we have of measuring things that we can't actually physically measure. What I mean by that is, you ever wonder how they get the distances between like the moon and the stars and the sun and all that stuff? They actually use trig. So if you, why'd my other thing go away? That's dumb. There we go. So yeah, they actually use trigonometry. They'll pick 2 points on Earth, or 2 straight points. Sometimes they'll use the space station to the ground. So it'll be like the International Space Station, the planet Earth, and then a point way the hell out in the middle of nowhere, right? You know, a star or a sun or whatever. Now, they don't know this distance right here, but they do know the angle because they can observe the angle from Earth out to the object, right? So they would know X, and they know the distance here, and then they can just use trig to figure out the distance here. So that's actually how they measure things that you can't like take a tape measure out and measure, like a laser pointer or whatever. They use trigonometry. So, I mean, we don't need that much on Earth anymore, but when we talk about space and everything, they're using trig constantly because that's the only thing we can do. Yeah, all right, moving on. So let's look at this guy. We're going to go through the same process because I'm a creature of habit, and I said that before, which shows how much of a creature of habit I am, right? So we're at this angle. We're going to go across from it to see if we have an opposite side, and look at that, we do. So we have an opposite side, and it happens to be 5 centimeters. Oh, this is a tiny triangle compared to the last one. And now my favorite thing to do, of course, after finding the opposite is looking for a hypotenuse. And when I look for a hypotenuse, I find nothing. No hypotenuse, no h, which should tell you if there's no h, then it can't be this one. Wait, whoops, I messed that up. Ignore that, I'm very wrong. If there's no h, then it has to be that one because this one uses an h, which we don't have. This one uses an h, which we don't have. So it has to be the one without an h. It has to be TOA. And that makes more sense as we look at what 4 is, because 4 is next to the angle, but it is not the hypotenuse, which makes it adjacent. Cool. All right. So we got OA, right? TOA, OA. So we set it up. Tangent of x degrees equals and then TOA is opposite over adjacent, opposite over adjacent. So opposite is 5 and adjacent is 4. Cool. And then, as we have been doing, we're going to do the inverse to both sides. I want to make this pretty, which is difficult. There you go. We'll do that. That's fine. Tangent to the -1 to both sides, right? This one cancels out, moves on to the other side. You have x degrees equals tangent to the -1 power, the inverse tangent. It's okay if you don't say it right or whatever. It's not a big deal. They use inverse and they use to the -1 power kind of interchangeably, regretfully. But. And then make sure we do it right. Opposite over adjacent. Opposite is 5. Adjacent is 4. Cool. All right. And we plug it into the calculator. These questions start going, I mean, as you've noticed, they go by quicker the more you learn about them and the faster you set them up. I mean, eventually, you're not going to do this situation where you move the trig function over. You're going to be like, I'm looking for an angle, so I use second trig, right? I use the inverse. But let's go through it. Our first side, the one that's on top, is 5. divided by 4. Then we hit equals, head over to trig, second trig function. There we go. So the angle is 51.34 degrees. That is how you solve for angles using trig. It's, in my opinion, pretty easy. I mean, it's the exact same way every single time. X is always in the same spot when it's an angle. So if you set up the equation correctly using SOHCAHTOA, then you'll get it right. There's no getting that wrong. So as always, if you have any questions, concerns, if you need any tutoring or whatever, go ahead and message me. We can set that up day of, I don't mind. But otherwise, there's a quiz. It's got 6 questions. You should be good to go. So I hope you have a great day and a better night and a good week. Peace out.